Okay guys, in this video we're going to look at the next application, which is related rates. So I believe that most of you guys is already familiar with related rates. You have seen that a lot. Okay, most of us, I believe, have seen it on the highway, right? For example, when you see a signage of a speed limit of 120 km per hour, that is a kind of related rates information. So what is actually related rates? It is actually a rates or a quantity changes by relating a quantity to other quantities. For example, of our speed limit just now, we are relating the speed with hour, right? That is the rate of change for the speed limit. Okay, so let's look at example 4.18 and discuss on how to solve this question. A spherical mothball evaporates at the rate of 8 pi cm cube per hour. How fast is the radius of the ball decreasing when the radius is 5 cm? Now, mothball is ubat gegat. Okay, and they are telling us that this mothball evaporates or becomes small and small at a rate of 8 pi cm cube per hour. In 1 hour, this is how much that it evaporates. Now then, how fast is the radius of the ball decreasing when the radius is 5 cm? So how fast the ball decreasing, right? So how do we solve this kind of question? First and foremost, as I have emphasized before, you'll need to write down every information given in the questions. Alright, so let's do that for this one. Okay, so this is what I can write down based on this question. Right, the evaporation rate 8 pi. Okay, and you might be wondering how can I write this down? This is a derivative, right? So it is a derivative. Derivative talks about change of y, x over change of y, right? So this is, what is it? And how can I decide that it is dv over dt and this dr over dt? You might ask. Right, look back at the questions. Alright, this is the evaporation rate, 8 pi. And we have information of cm cube over hour. The cm cube represent volume and hour here represent time. Hence, it is volume, the derivative of volume over derivative of time. The difference in volume over difference in time. So that's why it is dv over dt. Right? This is how I write it down, right? Makes sense now? Next, how can I put a negative 8 here? Right? You need to be sensitive in this issue because in applications, they will not provide you with whether it is negative or positive. Right? You will need to figure it out based on the situation that is happening there. For example, this spherical mothball evaporates. It means that the size of the mothball decreasing. In other words, it will decrease or reduce 8 pi cm cube in 1 hour. So basically, decreasing or reduction, right, is noted by this negative. It reduced. And how fast is the radius of the ball decreasing? And I did put dr over dt. How can I figure this out? So now let's first change this statement to more similar statement. I might say, how fast is actually you drive on a highway. You are going to say maybe I'm driving according to the law, which is 110 kilometer per hour. Alright, this is your answer. If I ask you this kind of question, how fast you go? So the same goes for this one. How fast is the ball decreasing? You will give the scale that being used for this ball, measurement of this ball, which is centimeter, and the radius, right? The radius over the time, right? For how long? So hence it becomes the RDT. So the question, there is the question, how fast is the radius decreasing when the radius is 5 centimeter? So we have another information, which is the information of R, right? So R is equal to 5. This is all the information, the information given. So our task now is to find dr over dt. Alright, so when it comes to application that involve shapes like this, now spherical moth ball, right? We all know that the shapes is a sphere-like shape, right? We have not a circle, a sphere, because 3D. So of course, to measure its volume, you will need to look at its formula of sphere volume, which is this. So let's do that. Okay, this is the volume. So we have, as you can see, we have several variables available here. We have the information of dV over dt. We have the information of volume. That is V in terms of R. We also have dr over dt that we need to look at later. So how do we find dr over dt? Right? In terms, in a equation of related rates like this, we can always use the idea of chain rule, okay, where you are going to construct the chain rule of dv dt or dv dr based on this, and figure out the dr dt. Now let's try to really make sense of it. Now we want to know how to look for dr dt. Right? If I were to, maybe I just go back a bit. Okay, based on chain rule, we know that if we multiply two other derivative that is in this form, dv over something times with something over dt, you will able to get dv over dt. So the next task is to figure out what is this unknown variable, the difference of this unknown variable. So look back at our information. Okay, we have the information of volume, we have the information of time, and we also need to have information of radius. So basically the derivative that we look at is related to radius, difference in radius, so dr. So let's look back. What information that do we have now? We have dv over dt, check. Do we have dv over dr? Not yet. Dr over dt, that is what we want to look at. So now, what are the information that we're able to find here? So we have this formula, which is dv over dr if we differentiate, right? So let's do that. Right, there you have it. Now we do have the information of dv dr and dv dt. So of course we should be able to find dr dt. Just substitute them, right, and try to solve for dr over dt. Right, note that I substitute this with the information of r given here when the radius is 5. So I get negative 2 over 25, right? So we now get the answer. The answer is, right, if you want to make a word out of it, we can say that the radius, the speed, right, or the speed of the radius of the ball decreasing when the radius is 5 is negative 2 over 25. Right, but to make it more precise, you should include the scale. What is the scale? We know that if it's about the speed of car, it is kilometer per hour. What about this one? What is the rate of change for this answer? right? Go back to the derivative. So dr over dt. So the radius here is in centimeter, right? We have centimeter in t. T here is in hour, right? So hence the answer is negative 2 pi 25 cm per hour. So that is for the first one, right? Thank you.